welcome back to my channel. I am Jishnu Yadav from Sri Venkateshwara College of Engineering, 4th SEM and ECE. Today's topic is Gaussian distribution function. Introduction to Gaussian distribution. The Gaussian or the normal distribution is a fundamental in statistics and probability describing the distribution of many natural and experimental phenomena. It's characterized by the symmetric bell-shaped curve as important applications across various fields. Definition and properties. Symmetry. The Gaussian distribution is symmetric about its mean, with the left and right halves of a curve being mirror images. Unimodal. In its single peak, the mean where the probability density is highest. Continuous. The distribution is defined over the entire real numbers line without any gaps or discrete values. Standard normal distribution definition. The standard normal distribution is a special case of the Gaussian distribution with a mean of 0 and the standard deviation of 1. Zero scores. The standard normal distribution allows up to calculate z-score, which represents the number of standard deviations a data point is from the mean. Applications. The standard normal distribution is widely used by hypothesis testing, confidence intervals, and other statistical analysis. Mean and standard deviation. Mean. The mean represents central tendency of the distribution and determines the location of the peak. Standard deviation. The standard deviation measures the spread or variability of the distribution and controls the width of the bell curve. The relationship between the mean and standard deviation. The mean and standard deviation together define the shape and characteristics of the Gaussian distribution. Probability density and function. Mathematical formula. The probability distribution function of the Gaussian distribution is defined by the specific mathematical formula. Visualization. It is represented as by the bell curve that illustrate being the probability of observing different values within the distribution. Applications. The applications of probability distribution functions are calculating probabilities and make the inference about the distribution of the random variable. Interpretation penetrations. The height of the PDF curve at the given point represents the probability density at the value. Cumulative distribution function. The cumulative distribution function represents the probability that random variables is then less than or equal to a given value. The CDF is calculated by integrating probability density function from the negative infinity of the desired value. Applications of CDF. It is useful for the finding probabilities, making interference, and constructing the confident intervals. Important in statistical analysis. Central limit theorem. The Gaussian distribution is a key component of the central limit theorem, which has profound implications for statistical inference. Hypothesis testing. Many statistical tests, such as the tests of and rely on the assumptions of normality, making the Gaussian distribution crucial. Modeling and estimation. The Gaussian distribution is often used to the model and estimate the parameters in a wide range of statistical analysis. Limitations and assumptions. Symmetry. The Gaussian distribution assumes symmetrical bell-shaped data which may not always reflect the real-world phenomenon. Outliers. The distribution is sensitive to outliers, which can significantly influence the mean and standard deviation. Skewness. Database with skewness or AV tails may not be well represented by the Gaussian distribution. Assumptions. The Gaussian distribution requires such as the independent and the homogeneity of the variacy to the valid. Conclusion. Fundamental concept. The Gaussian distribution is a fundamental concept that statistics has a widespread applications across the various fields. Importance. It plays a crucial role in statistical analysis, modeling, and inference, making it an essential tool for the data analysis and decision making. Limitations: the Gaussian distribution has the limitations and assumptions that should be carefully considered when applying it to the real world data. Continuous learning about the Gaussian distribution is understanding the Gaussian distribution and its applications is an ongoing process that requires continuous learning of and exploration about this concept. Thank you, friends. Thank you.